Right, so let's have a look. We're going to look today at inequalities and equations, and we're going to start off right at the beginning. So we're starting off with some very straightforward stuff. We're going to look at some linear inequalities and essentially work from the grade 5 questions all the way up to the level 8-9 questions. So we're starting off here with, so essentially this is going to be very, very straightforward how this topic starts, which is a linear inequality question, and we're going to start off with a grade 3 question. So if you were asked to do, and if you had to represent something on a number line, so you're representing an inequality on a number line, so this is sort of a grade 3 question at GCSE. Like we said, we're going to work all the way from grade 3 up to level 9. So -2, let's say, is less than x is less than 4. So that would be the type of very straightforward question you would need to do with an inequality. Now, this sign here is telling you x is bigger than, and this is telling you x is smaller than. So the mouth opening bit, if you like, is towards the x, so that's the bigger than bit. The other bit is smaller than. On a number line, we know that -2, -1, 0, 3, 4. The numbers we have, we represent with a circle, and we're going from there to there. We're joining up with a line. If it was also equal to, we would make the circles thicker. So that's the first type. And then we're going to go into the second type, which we're going to look at now, which is solving linear inequalities. And that takes you up to a grade 4-5 sort of question. And then as you have things on both sides, that takes you even higher. So let's start with inequalities in general, just to get you going. So to make sure you remember how to solve an inequality. Or how to just solve an equation. Let's just start with solving an equation. So you've got 2x, say +5 equals 23. So you're going to cover up the thing that has the thing that you don't know. So the bit that you don't know is 2x. So if you covered that up and you've got 23, take away 5, you know that something +5 equals 23. That something is 18. Something times 2 gives you 18. That something must be 9. So that's a very straightforward equation. But now we're going to put an inequality into that. So an inequality tells you that two quantities that are not equal. So you solve it exactly the same, like we did with that equation above. We're going to solve it in the same way. So if instead of an equal sign, I had said 2x + 5 is greater than 23, I would do exactly the same thing. I would cover up the 2x and say something +5 is greater than 23, right? That something must be the same as 18. So you might have done it like this at school, where you -5 from both sides. So you get 2x is greater than 18. Something times 2 is greater than 18. You divide by 2 there, divide by 2 there, and you get x is greater than 9. So that's a very, very straightforward linear inequality. If I then wanted to represent it on a number line, I would have 0, 1, 2, 3, 4, 5. Sorry, I started at 0 for some reason. 6, 7, 8, 9. I shouldn't have started at 0. I should have just started at 10. But it's from 9 and it's ongoing because it keeps on going. It's everything bigger than 9. So sometimes when we get those answers, we need to represent them on the number line. So let's have a look at a few more where it's a little bit different. So here I've got x is greater than 4. Let's say x is greater than or equal to 4. if I had x's less than 6, x's less than or equal to 6, and let's do one where we do something between the two. So let's say we have x is bigger than 2, but less than or equal to 9. If x is bigger than 4, that means if I have a number line, 2, 3, 4, 5, 6, I put a circle on the 4, the open sign towards the x is bigger than, so it's everything that's bigger than. If it's bigger than or equal to, what I need to do with that is I need to colour in that circle, but the arrow is still, so equal to means it could be 4, 5, 6. Bigger than 4 means it has to be, it could never be 4. It's something that's bigger than 4. And then you've got x is less than 6. So 2, 3, 4, 5, 6, 7, 8. So that's, if I've got my circle at 6, because it's not equal to, and I want everything smaller than, so I'm going to the left. And then less than or equal to, exactly the same, except this time I'm going to like colour in my 6. And I'm going that way. So if you get something like this, so 1, 2, 3, 4, 5, 6, 8, 9, you've got your circles on your numbers. I've got a circle on 2, a circle on 9, but the 9 has an equals to next to it. So I'm going to colour it in. I want everything between the two numbers. So I want to know greater than 2 and less than or equal to 9. So I'm going to join it up like that. So those are my inequalities on number line. And if you get asked to say what integers, so you might get a question like this, and you might need to list the integers that represents. Integers just means whole numbers. So if what whole numbers are bigger than 2, but less than or equal to 9, that would be 3, 4, 5, 6, 7, 8, and you would have to include that 9. Okay, so that's the first, solving the inequalities, putting them on a number line takes you to your level 4, 5. We're going to do a few more practices of solving a few inequalities and putting them onto a number line. And then we'll look at the level up, which is like a 5, 6, when you've got an inequality on both sides. So let's just do 2 or 3 examples of these. So if you have 4x minus 5 is bigger than or equal to 2x plus 11. So we're going to solve this and put the answer onto a number line. So first things first, we want all the x's on one side. I usually choose the side with the most amount of x's, so you don't end up with negatives because they're just annoying. So we're going to put everything onto the left. So I'm going to minus 2x from this side, minus 2x from this side. So that's going to give me 2x minus 5 is bigger than or equal to 11. I'm then going to add 5 onto both sides to get rid of it onto the other side, because we've got something minus 5 is bigger than or equal to 11. So if I add 5 on this side, I add 5 onto this side, I've got 2x is bigger than or equal to 16. So that's 2 times something is bigger than or equal to 16. Divide both sides by 2. And you've got x is bigger than or equal to 8. To put that on a number line, let's do 6, 7, 8, 9, 10. It's equal to, so it's a circle coloured in. And I want everything bigger than. So I've got an arrow going towards that way, going to the right. Okay, so we're going to have a look at something that's going to be a little bit trickier. So where this gets tricky is when negatives are involved. You can add and subtract numbers on both sides. You can multiply things to both sides, but when you multiply or divide by a negative, it flips the sign. So this is why. So for example, I know that 2 is greater than 1. Yeah, so 2 is the bigger number, 2 is bigger than 1. Now, if I multiply both of those sides by -2, what happens? The 2 becomes -4 and the 1 becomes -2. Now, if you think of a number line, got 0, -1, -2, -3, -4, 1, 2, right? We can see that -4 is smaller than -2. So what's happened is the sign has flipped. So whenever you multiply or divide by a negative, your sign is going to flip. So you're going to go from being greater than to being less than, or from being less than to greater than. So let's do an example with that. So if I had 16 is greater than -4x. So let's say to start with, I just divided it by 4. I'm going to divide by 4. That's going to become 4, and that's going to become -x. But in order to bring the x onto the other side, I'm going to have to, I have to multiply everything, effectively multiply everything by -1. So I have to change the sign. So I'm going to get x is actually bigger than -4. So if on the number line, and if you're ever unsure whether you've done it the right way, just plug a number in and see if it works. So put a number into your first bit. Say you could put 1 in. So you'd say 16 is greater than, and you double check that works with your answer as well. And if it works, then you know you've done it right. So you switch the signs when you multiply or divide, or you just get rid of the minuses on both sides. So let's just do one more example like that, because that's like a classic mistake. And it's very frustrating when you see someone's done lots and lots of working, and on that final step, they don't get the mark. All right, so I've had this. Let me move the 7 onto the other side. So I'm going to -7 on this side and -7 on this side. I get -2x. So 3 minus 7, so getting smaller by 7, takes you to -4. And now to get x on its own, I have to divide by -2. Right? And now if that confuses you, you could just divide by 2. So say you just divided by 2 to start with, you'd get -x is less than or equal to -2. And because you need to get rid of those minuses on both sides, you need to flip the sign. And to represent that on a number line would essentially be, 1, 4, 5, 6. So it's equal to, so I put a circle into it, and it's everything bigger than. Okay, so now let's look at one level up. Now it's still staying with linear inequalities, meaning there's x's, but not x squareds. So we're staying with inequalities, but looking still at linear ones. We will move up to the quadratic ones. You could have something where you have something on both sides. So I could have 2x minus 1 is greater than x and less than or equal to 7. All right, so this is taking you up to a level 6 question. Generally, it's level 4, 5. This is more a 5, 6 question. What you're going to do is split this. So essentially, you're going to treat it as 2 separate inequalities. You're going to keep each bit separate. So if we take the left-hand side first, we're going to have x is less than 2x minus 1. And on the right-hand side, we've got 2x minus 1. Oh, sorry, I've put an extra x in. So we've got 2x minus 1 is less than or equal to 7. So step 1, I'm going to expand. So when I expand out, let's do one at a time. So we're going to do the left-hand side first. I'll get x is greater than 2x, 2 times x, and then 2 times minus 1 to give us minus 2. I want all the x's on one side, generally on the side with more x's. So I'm going to move it onto this side. And minus x from both sides. I'm going to get 0, x minus 2. I'm going to add the 2. So I'm going to get x is greater than 2. Okay, let's look at the next side. Expand. 2x minus 2 less than or equal to 7. I'm going to add 2 on both sides. I get 2x is less than or equal to 9. And now I'm going to divide both those sides by 2. So I'm going to get x is less than or equal to 9 over 2, which is 4.5. Now I have to combine the answers. So I can see x is bigger than 2. So x is bigger than 2 and less than or equal to 9 over 2, which, like we said, was 4.5. If we had to represent that on a number line, we've got 1, 2, 3, 5, 6. So I'm going from 2, and at 4.5, it's those two, so something like that. So that's if you've got something on both sides. If you want more practice on these, I'll upload some stuff onto the onto the Google Classroom. Can't get my words out, and you can have a look at it there. So we've got these inequalities. This takes you up to a grade, I'd say a grade 5, 6 level. So this could definitely come up at grade 5. So what we're then going to look at is how that then goes up a step and we take it a step further. So now we're looking at the 7, 8 levels, but in order to be able to do the inequalities, you need to be able to sketch a quadratic curve, because they sometimes link it to the sketch and ask you to sketch a quadratic. So let's have a look at what a quadratic is. So a quadratic is essentially something with a squared. So what you've already done and what you've already looked at is things like factorizing them. If you haven't, looked back at some factorizing stuff. So we'll have a look at that. So let's have a look. So let's have a look at x squared plus 5x plus 6. So you should know how to factorize these. If you don't, make sure you get some practice. It's a really important skill. You're looking for your factors of 6, that when you add up, you get 5. So you get 3 and you've got 2. You add them up and you factorized it. So that's the first step. That's one of the things you need. You also need to be able to complete the square. So when you complete the square, in order to be able to complete the square, you look at the number in front of the x and you half it. And when you do that, you get x minus 3 squared, and then you square this number to give you minus 9 plus 13. So we get x minus 3 squared plus 4. Now, if you're not sure of those skills, you can always go back. You can still do this. You can still follow through this lesson, even if you're not sure how to do that, because I'll show you what the sketches look like. Or I'll do the factorizing as part of it. Oh, God. So positive quadratics. So that is when your x squared, the thing in front of your x squared, which is called a coefficient, is positive. You get a smiley face. So when it's positive, everyone's happy. You get a positive x squared. Negatives are like not a U shape, they're an N shape, they're a sad face, they're a bit, they look like. So a negative, this would be minus x squared. So that's a negative quadratic. So that's the first thing you have to identify. The same thing you do when you look at straight lines. Is it a positive gradient? Is it a negative gradient? The first thing you're thinking of in your head when you're sketching a graph is it positive? Is it negative? Once you've got that, you can then plot and think about all the different points. So let's take a typical graph. Got X and we've got Y. Got a graph like that. So first of all, I've looked at it. I'm like, okay, I can see it's positive. I know it's going to have this shape. I'm going to have a point where it crosses the x-axis. Actually, I'm going to redraw that. So the minimum point is not where it crosses. Okay. So I'm going to have a point where it crosses the x-axis. So in a linear equation, when you have y equals mx plus c, it's your plus c. Exactly the same here, because you're going to have something x squared plus something x plus c. So this plus c is this point here. So it's called your y-intercept. And you find this when x equals 0. Then you have 2 points, normally, where it crosses the axes. Now, this could be 1 point where it just sort of jumps and bounces up, like in x squared. So those 2 points are your x-intercept. And you find this by putting y equals 0. So you've got a y-intercept and you've got your x-intercepts. And then the new bit might be this point here, which we call a turning point. So the turning point we can find when we complete the square, and that's why we use completing the square. So the turning point, and it also gives you your line of symmetry, because these equations, quadratics are always symmetrical. My drawings are definitely not, but quadratics are definitely always symmetrical. So let's actually do one in 2 different ways. We're going to use completing the square, and we're going to do it using factorizing. So let's take an example. We've got y equals x squared, so the same example we had before. Right. So I look at this and I go, okay, this is positive. So I know it's a smiley face, so it's U-shaped. I have my plus c. So I've got my plus c, so 6 must be my y-intercept. To find out your x-intercepts, we said y has to be 0. So to find my x-intercepts, I'm going to make y 0. And hopefully this looks like a quadratic equation that you would be able to factorize. 2 and 3. And then we say either x plus 2 is 0 or x plus 3 is 0, which tells us x could be minus 2 or x could be minus 3. So now I've got my x-intercepts. So I've got my x-intercepts and I've got 2 of them. Minus 2 and minus 3. It's positive, so we know it's going to have a turning point at the bottom. But let's see, based on this information, what we can draw. So, okay. We don't really need the positive bit because both the intercepts. So we know it goes through x is minus 2. It's a sketch. It doesn't need to be pretty. I mean, generally maths doesn't need to be pretty. I mean, you don't need to draw something beautifully. If you want to use your rulers and but in an exam, if it says the word sketch, it doesn't need to be too pretty. It goes through 6 and it doesn't all need to be to scale. So we've got our x-intercepts, we've got our y-intercept, which is 6. So there's my 6. These are my 2 x-intercepts. And now we know it's a U shape. And this is where I should have drawn this first. Okay, so that definitely doesn't look beautiful. And that turning point, because the thing is, because we know that the whole graph is symmetrical, we know that exactly between minus 3 and minus 2, we're going to get our lowest point. It's going to be exactly halfway. Now, to find a point exactly halfway, we would add up the 2 points and we would divide it by 2. Or you could, I mean, in this case, it's really easy to see, it's minus 2.5. So we know that this point here is minus 2.5 is my x coordinate. If I had to work out the y coordinate, I could substitute that back into here. So when x equals minus 2.5 in my calculator, do minus 2.5 squared plus 5 times minus 2.5 plus 6. And that gives you minus 0.25. And you have sketched the curve in its entirety. Now, if you had been asked specifically, I think I said that right, I always say it wrong, to do it by completing the square, then the way that you would do that is, so let's do it using completing the square as well. So we had y equals x squared plus 5x plus 6. And say part A of the question was to complete the square. So we would half whatever's in front of the x, and that goes in the bracket with an x. And then we square that, which gives us minus 5 squared, which is 25, over 4 plus 6. So y equals x plus 5 over 2 squared minus a quarter. Now, if you remember, that minimum point that we had was 2.5 minus 0.25, which is the same as, you can see here, 5 over 2, and so minus, that's be a minus a quarter. So when you put something in completing the square form, x plus a squared plus b, your minimum point or your maximum point is always minus a b. But like I said, you don't need to do it like that if you can avoid it, because you can do it using whatever's exactly in the middle, because it's your line of symmetry. And you can actually work backwards. If you know your line of symmetry, you can plug in this a and b, and you've completed the square. So if it's something that factorizes, that's another way to complete the square. So let's take, we're going to take an example that, okay, so let's take an example which sometimes trips students up, even though it's very straightforward, because it looks a little bit different. So if I said y equals x squared minus 12x. So straight away we go, okay, it's a smiley face, it's U-shaped, because it's a positive x squared. So we know that it's U-shaped because it's a positive x squared. We know when there's no plus c, which means our plus c, so we know our y-intercept must be 0. To find the x-intercept, we're going to make y equal to 0. So 0 equals x squared minus 12x. We can factorize the right-hand side, take x outside the bracket. Now what this tells us, and this is the bit you have to be careful of, is x equals 0 or x minus, sorry, in this case it's not or, it's and, because we've got 2 intercepts, x minus 12 equals 0. So we end up with x equals 12. So now we have x is 0 and 12. So now we can go sketch it. And what I'm going to do this time is draw it first, and then still wasn't very pretty, and then put the numbers in. So we know 1 point is 0, which is your y-intercept and it's your x-intercept. This is 12, and we can see that our midpoint right in the middle of 0 and 12 is going to be 6. So the x coordinate is 6. We do 6 squared minus 12 times 6, we get 36. So therefore we can see that our minimum point, or our turning point, and that's minus 36, sorry. Our turning point is 6 minus 36. And that gives us how to sketch a graph, which, like I said, was a key skill that we're going to need now to do our quadratic inequalities to take us to the end of this, you know, this chapter, if you like, or the bit that's quite difficult that takes you all the way to level 8-9 questions. So what we've had is we had our inequality that we represented on a number line. We solved a quadratic equation, which takes you to like a level grade 6. Now you're going to solve a quadratic inequality, which is a level 8-9 question. So let's take a quadratic inequality and go through it step by step. So you can have x squared plus 3x minus 4 is less than 0. Right, so we could factorize this. We get x plus 4, x minus 1, right? And what, actually, even before we do that, the best way to do this, actually, is to say, let's sketch that graph. So I'm just going to say y equals x squared plus 3x minus 4. And we're going to do a quick sketch. This is why I said nothing has to be beautiful. So we've identified positive x squared as a smiley face. X plus 4 can be 0. So x is minus 4. X minus 1 equals 0. So x can be 1, right? So, and we can see our plus c is minus 4. So a very quick sketch is going to give me something like that. And I'm going to put my numbers in. So 1 minus 4 minus 4. In this case, we don't need a turning point to be able to do this. And now we want to know everywhere where the graph is smaller than 0, because we want less than 0. So when it's underneath the y-axis. So where is this graph underneath the y-axis? And hopefully you can see it's all of this. So if we imagine our x-axis is our number line, we've shaded in everything between 1 and 4. So essentially, x has to be bigger than minus 4 and less than 1, because it's all of this space in the middle. So that's how you decide whether you have the outside section or the inside section. Now, a lot of the times this can be confusing, and a good way to check, remember in an exam, you always want to do like a helicopter test. You have to look at something from above and you say, does this make sense? So pick a number in the middle. If you can pick 0 because it makes life easy. 0, if we're right, should work when we put it into that equation. So we're going to do 0 squared plus 3 times 0 minus 4, which gives you minus 4. And you say, is minus 4 smaller than 0? Yes, it is. Okay, I've definitely done this question right, because the number that I chose is smaller than 0. So you can't get these wrong, or you shouldn't really get these wrong. So now let's try a negative one, because we didn't really even sketch a negative one. So if I take minus x squared plus x plus 6 is greater than or equal to 0. So step 1, we're going to try to do a quick sketch. So y equals minus x squared plus x plus 6. Right, I've in my head gone, okay, it's a minus in front of the x squared. I know it's a sad face. I know it's a negative. Okay, I want to factorize it, but I have this pesky minus there. So what I'm going to do is I'm going to leave the minus outside. I'm going to take minus 1 outside the bracket. When I do that, all the signs change. And then it becomes something that I know how to factorize. So I get x plus 2, x minus 3. Okay. So it doesn't change anything. The fact you've taken that minus outside, I can't talk today. Your limits are still the same, so that your roots are still the same. You still have x plus 2 equals 0 and x minus 3 equals 0. The minus just tells you that it's going to be a a sad face, a negative quadratic. So let's draw that. So we're going to do like that. I've got -2, got 3, and I've got a 6 here. So that tells me that number there. And because it's minus, I've done it the other way around. And now I want everything that's bigger than or equal to 0. So everything on top of the x-axis. So where there's a positive y. So I want everything on top. So that's going to be all of this bit here. And if I imagine that to be a number line, it's between -2 and 3. So that's x has to be bigger than or equal to -2. Now, the reason it's equal to is because in the question, it's an equal to sign. So it's as if on that number line stuff we did with the linear ones, you've done a circle. Okay, and that essentially takes you all the way from your level 3 questions till your level 8, 9 questions. So I hope that was useful. I'm going to take 10, 15 minutes, and then I'm going to look at moles, some of the quantitative chemistry stuff, so moles, balancing equations, and then we're going to go all the way up to looking at some of the limiting reactions and percentages yield. So take you from it's all the stuff from the foundation paper, but it takes you from right the way up to sort of some of the combined stuff at higher level, but not the higher single level stuff. So the idea is to do some chemistry. It's about 10 to 6, so I'll start the chemistry at 6. If anybody wants to join, you're very welcome to, and I hope that was useful. And I shall see you then. Let me